Now let's think about another possibility. So in this possibility, both proposals are making the same amount of offer as star, but their offer is less than 1. So we're gonna show that again this cannot be equilibrium. So why? Let's think about. So suppose in the point of view of first proposal, in the current situation, what is first proposal's payoff? So let's think about first proposal's payoff. In this case, because first and second proposals offer are the same, responder is gonna choose one of those two offers just randomly. So with probability 50%, first proposal's offer is gonna be accepted, and with remaining 50% probability, second proposal's offer is gonna be accepted. Therefore, with probability 50%, we're gonna write down first proposal's payoff when first proposal's offer is accepted. And with probability 50%, we're gonna write down first proposal's offer when second proposal's offer is accepted. So here we are calculating expected payoff of first proposal in the current situation. So let's think about the first part. Let's think about blue part. So here in this blue part, we're gonna calculate first proposal's payoff when first proposal's offer is accepted by responder. So in this case, remember first proposal and responder are gonna share the resource. So responder is gonna get S star, and first proposal is gonna get the remainder, and second proposal gets nothing. So second proposal gets nothing. So therefore, first proposal in this case obtains 1 minus S star. And we have to think about inequality. First proposal is gonna feel envy about responder. So alpha term is about inequality between responder and first proposal. So in this case, responder has S star, and first proposal has this much. So this expression is inequality between responder and first proposal. And first proposal is gonna feel compassion about second proposal because first proposal has more than second proposal. So here comes the inequality. Here we're gonna have inequality between the two proposals. So in this case, first proposal has 1 minus S, and second proposal has nothing. So here in this blue expression, we have first proposal's payoff when first proposal's offer is accepted. And in this green expression, we're gonna calculate first proposal's payoff when second proposal's offer is accepted. So in that case, responder is gonna share resource with second proposal. So responder is gonna get S star, and second proposal is gonna get 1 minus S star, and first proposal gets nothing. Then in this case, first proposal's consumption is 0, and first proposal is gonna feel envy about both responder and second proposal. So we're gonna have alpha. So first part, inequality between responder and first proposal. So it is S star minus 0. And the second part, inequality between second proposal and first proposal. So combining this blue and green expression, we can calculate first proposal's expected payoff under the current situation. So let's call this blue expression as A and green expression as B. We can see that this green expression B is equal to minus alpha over 2. We can show that A is bigger than B. So why is this true? So A part. So by rearranging A part, we have so we're gonna use a similar argument as before. So this is A part. We can see that this expression is positive. So we can see that this expression is positive because we have 1 minus S star here. So we have 1 minus S star, 1 minus S star, so same number. We know that beta is less than 1, so this is a fraction. So this expression must be positive number. So if I take away this positive number, then I get smaller expression. And this blue expression here is less than 1 because S star is less than 1. So therefore, if I change this blue expression to number 1, the expression is gonna get smaller. So therefore, this is number B. So we can show that A is bigger than B. So under the current situation, first proposal's payoff is equal to half times A plus half times B. So So first proposal's payoff is equal to half times A plus half times B. And we also know that A is bigger than B. Therefore, so here we have A, here we have B, and in the middle we have first proposal's payoff under the current situation. So okay, now imagine, so remember on current situation is this. So this is current situation. So there is a number S star. This number is less than 1. And both proposals offer exactly S star. Then now suppose first proposal change its choice to S star plus epsilon. So first proposal and second proposal are offering exactly S star under the current situation. Now imagine first proposal is changing its choice, and this new choice is S star plus epsilon. So first proposal is slightly outbids the other proposal. And let's see what's gonna happen to first proposal's payoff. So if we change his choice, then first proposal's payoff becomes, so in this case, responder is gonna choose, first proposal's offer, because this is first proposal's offer and second proposal's offer is S star. So first proposal offers more. So responder is gonna choose first proposal's offer in this case. Therefore, first proposal and responder are gonna share the resource. So responder is gonna get S star plus epsilon. First proposal is gonna get the remainder, and second proposal gets nothing. So in this case, first proposal payoff is, first his consumption is this. And first proposal is gonna feel envy about responder because responder has more. So here comes inequality between responder and first proposer. So here this blue expression is inequality between responder and first proposer. And from this inequality, first proposer feels envy. And first proposer is gonna feel compassion about second proposer because second proposer has nothing. So first proposer has this much and second proposer has nothing. So this red expression is inequality between these two proposals, and first proposer feels compassion from this inequality. Okay, then so let's look at this purple expression. we can see that if epsilon here, so in this purple expression, we have epsilon in many places. So if you compare this purple expression with number A, so expression A, so if you compare expression A and this purple expression, if in this purple expression epsilon is equal to 0, then these two expressions are the same. So if you compare expression A and purple expression here, if epsilon is equal to 0, then these two expressions are the same. And remember, epsilon is a very small positive number. So epsilon is a very small positive number. And if epsilon is equal to 0, this purple expression is equal to expression A. Therefore, what we can see from here is, as long as epsilon is a very small number, this purple expression is going to be somewhere near expression A. So as long as epsilon is a very small number, so if epsilon is very small number, this purple expression is gonna be very close to expression A. So somewhere very near to expression A. Then we are done because what is this purple expression? Purple expression is first proposal's payoff from choosing S star plus epsilon. But under the current situation, first proposal's payoff is here. Therefore, we can see that under the current situation, first proposal's payoff is here. But if first proposal change its choice to S star plus epsilon, we can see that his payoff is increasing. Therefore, current situation, so this is current situation. So this current situation cannot be equilibrium because first proposal has incentive to change his choice. Okay, then the remaining possibility is this. So the only remaining possibility is this situation. So what's happening in this situation? So here, both proposals are offering the same amount, and in this case, both proposals are offering the entire resource to responder. We're gonna show that this is equilibrium. So if this is equilibrium, now we can see that standard theory and FS model both predict that both proposals are offering the entire resource to responder. So prediction from standard theory and FS model are the same. So they are equally well explain experimental findings from market gain. So why is this equilibrium? So think about first proposal. So if we think about first proposal, we can see that under the current situation, what's happening? So under the current situation, they are offering the same amount. So responder is gonna choose one of those two offers randomly. So with 50% first proposal's offer and with 50% second proposal's offer is gonna be accepted. So if first proposal offer is accepted, then responder and first proposal are gonna share the resource. So in this case, responder is gonna get the entire resource, and so number one, and first proposal is gonna get nothing, and second proposal is gonna get nothing. What if second proposal's offer is accepted? In that case, second proposal and responder are gonna share the resource, and responder is gonna get 1, second proposal is gonna get 0, and first proposal is gonna get 0. And we can see that in this case, resource allocation is the same regardless of whose offer is gonna be accepted. So resource allocation is always responder gets the entire resource and both proposals get nothing. So in particular, we can see that first proposal's allocation is always the same. So in any case, resource allocation is always the same. So responder gets the entire resource and both proposals get nothing. In this situation, what if first proposer change his choice? So first proposer change his choice, it means that so under the current situation, both first proposal and second proposal offers exactly 1. So if first proposal change his choice, it means that now first proposal is gonna offer something less than 1. Then what's gonna happen? Responder is gonna choose. So responder is gonna accept the second proposal's offer. Therefore, in this case, what's gonna happen? Responder is gonna get the entire surplus, and second proposal is gonna get nothing. And first proposal is gonna get nothing because first proposal's offer is not accepted. So we can see that resource allocation is again the same. So there is no change in resource allocation. So therefore, even when first proposer change his choice, resource allocation is the same. Therefore, there is no change in first proposer's offer. So to be precise, you can calculate. So you can write down first proposer's payoff under the current situation, and you can also write down first proposer's payoff when first proposer change his choice, and you can see that payoff is exactly the same. So here we have exactly same payoff because resource allocation is exactly the same. Therefore, first proposer has no incentive to change his choice. So current situation, so this green situation is equilibrium. Okay, so this is prediction from FS model. So to summarize, we thought about market game. In particular, we thought about two proposal. So two proposers and one responder case. So here we thought about market game with two proposers and one responder. And when we do experiment, we find very different result relative to ultimatum game experiment. So in ultimatum game experiment, we typically find the proposer offers less than half, and it is often accepted and rejected by responder. But in market game experiment, we typically find that proposers offer a lot of resource to responder. And oftentimes, researchers find that two proposers offer almost entire surplus to responder. So we thought about standard theories prediction and FS models prediction. And we find that both models, so standard model and FS model, predict that both proposers offer the entire resource to responder. So this is the prediction of these two models. So we can see that both standard theory and FS model can reasonably well explain experimental findings from market game.